What's up, guys? This is Milos. Welcome back to my channel as I take you on a journey to creating global trade routes. In this tutorial, we'll be using United Nations Comtrade data to visualize global wheat exports from different sources. So the first thing I will show you is how you can register and get the API key to query Comtrade data. The second thing, I will show you how you can create the data using a package in R. And finally, I will show you how you can create some really pretty and also effective global trade route maps. Okay, so our first step is to install and then load the packages that we need. And one of the packages that we need to install from the GitHub is Comtrade R, which is a client package which will help us communicate with the Comtrade API and then get the data that we need. So for that purpose, we first of all need to install one of the packages, which is called DevTools. And we are installing DevTools because DevTools itself has one function which is called install GitHub. So this is going to help us install directly this package from the GitHub repo, and this is actually the GitHub repo. The next thing is to define also other packages that we need, and here I'm going to put them into a list called libs. So the first one that's we need is the Tidyverse umbrella package. From this one, we'll be using dplyr for data wrangling and ggplot2 for creating maps. The second one is, of course, this Comtrade R package, which we installed in the previous tab, but we will definitely need to also load it into our R session. Now we will also need the world map to show where the trade routes from a single or multiple points go. And for that, we can use Gisco R, which provides shapefiles for any country or region in the world. The next package is the SF package, because we will be working, of course, with shapefiles, and they're going to be in the SQL features or SF format. To create these lines or great circles, we will definitely need the SF headers package, which is going to make our lives much easier from converting the points to lines. And then finally, we will be connecting the points from the capitals of these countries on trade routes. And for that purpose, we can use one package which is called Coordinate Cleaner, which provides coordinates for any capital cities in the world. Okay, now that we have this list of packages that we need, we first of all need to check if they are installed in our system. So what we're doing here is we're saying, okay, let's take this list of package names that we have, and then let's go to the role names of already installed packages. If they're not installed, we need to install them. So for that purpose, we're gonna be writing here an if-else statement. So if any packages from this list are not installed or they equal false, well, we need to install them. So we say simply install packages, but we don't need any packages here. We of course need those from this libs list that are not among the install libs. And finally, we also want to install the dependencies, some of these packages. Now, once we have this installed, the last step is basically to load these packages into our session. And that's actually pretty straightforward. What we just need to do here is we need to apply the library function in R to this library list, and the library function actually just loads all these packages. Okay, so the very first step to get the Comtrade data is to register, log in, and then get the API key, which is going to help us fetch the trade data. So we're here at comtradeplus.un.org, and the first thing I'm going to do is go to this login tab, and I'm going to click here. So this opens a new dialog box where you can either sign in with your existing credentials, or you can sign in with your social account. So either your un.org account or your Google account. There's of course an option here to sign up, where you go through the whole process and register yourself. Now, I'm not going to do that. I'm just going to go for my Google account. So I'm going to click here on Google accounts, and then I'm going to select my Google, of course, credentials. Now, here you need to fill out some name, of course, not names, but details. So your display name, your given name, surname, and organizational code here is not really necessary. So once you are actually done here, basically, it's just going to scrape the data from your Google account and put it here. You can just click on continue here. If you successfully logged in, you should be able to see my Comtrade free tab here with 3 possible options in the list: my profile, my API portal, and my saved list. So we're going to click on my profile, which is just going to give us some account details, but you might be wondering, where is my API key? Well, actually it's not here because first of all, you need to subscribe to a free APIs because they're also paid APIs. And to do that, we go back to this My Comtrade Free, and then we click on the second option on the list, which is called My API Portal. So this is gonna offer us the opportunity to explore APIs. So over here, we click on the Products tab. And here, there are several, of course, APIs that exist. As I said, the first one is the free APIs. This is what we need. For these, you do not require authorization. So everything else are paid or premium APIs. So we need to click on this free APIs link. And this will take you to the page where you can subscribe to one of the APIs. So here, what we want to do is take from this list here a Comtrade-V1. So we will be subscribing to that one. We copy that name, we paste it here into this box, and suddenly this subscribe button becomes yellow. So you need to click on this subscribe button. And then once you click, it will actually then make you subscribe to it. And it's going to immediately take you to your user profile page, where you can see not only now your account details, but also your subscriptions. So you will have here your primary and your secondary key. In order to see your either primary or secondary key, which you will need, you need to click here on show either the primary or secondary. And once you click show and you copy it, we're going to go back to R and use Comtrade R to fetch the data we need. Okay, I hope you managed to register and to get your API key. The next thing is to register our API key using Comtrade R. So let's call Comtrade R, and then I use here set primary Comtrade key. And here in double quotes, you need to insert your API key. And once you insert it here, you can run this, and this is gonna register your primary Comtrade key. So then the next thing is to explore a bit what is, in this data set. What are the possible codes that exist there? So here I'm gonna be creating maps of wheat trades. And for that purpose, I'm gonna search everything that has wheat in this database and see what we can fetch here. So I'm gonna create an object called wheat codes, and I'm gonna use Comtrade R and call function which is called CD commodity lookup. So this is going to create a lookup table with all the details for the string you want. So I'm looking here for wheat. You can search for anything else which is commodity or a service that can be a trade, and that exists, of course, in this Comtrade database. Then the second thing I'm saying here is I don't want to return the codes, but I do want to return the full description here. So I'm putting here return char equals true. All right, and then once we actually run this, what we can do next is simply print this thing and see what is that we can find that contains wheat. Okay, so there are several things here. There's actually quite a lot of things on this list. As you can see, what I'm interested in, what I want to take is the general just wheat and maize here. So this is 1001. So we will be using this code 1001. If you want to use anything else, always the most important thing is that you copy this code number. So without the characters. All right, so once we have this, the next thing is actually to get the data. So in this first part of the tutorial, I will show you how we can fetch the data, analyze it, and then also map it for a single exporting country, and then all of its partners that are importing wheat from it. And in this case, we'll be using Ukraine, which is one of the major exporters of wheat, and we'll be using the freshest data, which is for 2022. Here is how we're going to do that. I'm going to create here wheat exports objects, and then I'm going to call, of course, Comtrade R. And then there is a function here for getting the data. It's called CT get data. So within the CT get data, there are actually many parameters that you can choose. But some of these things that we need to actually input here is, of course, commodity type or commodity code. So as we said, it's 1001, but here you need to provide in the form of a string, and that's why I'm putting double quotation marks. Okay, so that's the first thing. The second thing is the flow direction that you're gonna, explore. So it can be import, export, or re-export. I'm interested here in exports. So exports are wheat from Ukraine to any other country in the world for 2022. So the flow direction equals exports. Right? Exports. Then the third thing is the exporting country, which is called reporter. And here you can select multiple, but let's start only with one. So here you need to provide the ISO 3 codes For Ukraine, that's UKR. All right. And then I want to have all the countries to which Ukraine exports wheat. So these are partner countries. So partner equals to, and if I want all, I can simply write all. I don't need to get the list of all the world countries. So this is a very, very convenient function. And then for the start date and end date, there are two options. If you're using dates, you need to specify the date in the form of a string. But if you are specifying only years for which you want, like we want, I'm just going to put here the number of the year. All right, so that's the start date, and the end date is also 2022. So this is what is this? This is going to return the data only for 2022. Okay, and then if we explore this newly fetched data frame, we can see a bunch of columns, and we don't really need all of them. What we definitely need here is this partner ISO. So this is ISO 3 code, because this is going to help us down the road also fetch the capital coordinates, capital city coordinates for each of these partner countries. Of course, if you're interested in the names of countries, there's also this partner description. So this is going to offer you the country name. Then the second thing we're interested in this bunch of things is, of course, the quantity. So here, what you can take here is the quantity here, and the quantity is in kilograms, because this is the quantity unit abbreviation, so kg. So we'll be using here quantity in kilograms, and we might actually turn them into tons because this looks pretty big. So that's the second thing we need. And then there are also some other things that you can also fetch. For example, what is the value? I guess this is in dollars. So what is the value of these exports? But for now, I'm just going to focus on the quantity in terms of kg. So once again, what we need here is the ISO 3 codes, and of course the quantity of the exports from Ukraine to every specific country. Okay, so let's select only those two columns and create here an object called wheat df. So let's work from this wheat exports, which is quite a complex table. And then let's use select from dplyr. And as I said, let's fetch partner ISO codes. And then the second thing is the quantity denoted here by QTY. So far, so good. We have the trade data. The next thing is to get the from to point so that we can then build those trade lines between Ukraine and the capitals of any other countries. And speaking of capitals, this is where we can use this data cleaner or coordinates cleaner package that we just imported, because this one actually has a data set which is called country ref. Or basically country references. So you can call it by just running this data country ref. And then you can also explore the first few rows of this data set. So we will actually do that. The reason why I'm using this data set is the following. It has information for every country on either the centroids of that country or the coordinates of its capital city. Now, one thing you might actually here notice, the first three rows, we have Afghanistan and then we have Kabul. And you might be wondering why Kabul has actually 3 entries, it should have only 1, where there are actually different measures here of the Kabul coordinates. So what we will do next is we will simply take the maximum value of these coordinates, and this will give us, or we can also take average, but this will give us actually then only one pair of coordinates for the capital city for every country. All right, so what do we need here? We need actually this capital.mon, capital.lat, and of course we need this ISO 3 column. All right, let's get down to business and create a new data frame, which we're going to call capitals. So this one is of course going to be based on the country ref. We built here a pipe, and then the first thing we want to do is filter out all those that are actually missing. So everything that is NA, we're gonna cleanse. So everywhere where the capital name is NA, we're just gonna remove that. And then we are gonna go and group by. So we're gonna group by, as we said, because we have here in this table multiple coordinates, we need to only get one. All right, so we in that case are gonna group by ISO 3 code and also the capital name. We can even just do ISO 3 code because we don't really care about the capital name, but it is what it is. All right, so the next thing is then to get the maximum values. So I'm going to use here summarize at, and then the variables for which we want to get the maximum, you can also take the average values, are, as we said, capital.lon. That's the first one. And then the second one is capital.lat. Okay, and here you need to specify what you're gonna calculate. So we're gonna calculate here the maximum longitude and latitude values for every capital. And then the very last step is to simply rename this. I just want to have long and lat for the names. So I'm using a rename from dplyr. With rename, you first of all put the name that you want to have, and then second, what is the old name, what you want to replace. And then I will also replace this one for the latitude. So latitude equals then capital.lon. Now we can use those capital city coordinates to create our points and then coerce them into the SF format. We're going to start off with ending points or end coordinates. So these are the countries that import wheat from Ukraine. And here we will work on this wheat VF. Of course, we need to join it to this capital or capitals data frame that we just created. And we're going to do here left join to the capitals. Now, you probably noticed that the ISO3 name is different in these two. So in the wheat VF it's called partner ISO, and in capital it's called ISO3. But fear not, there is a way also to join them even when they have different. We need to specify here as a list for each of them what they have. So starting with the first one, it's partner underscore ISO, and that equals to ISO3. So this is going to solve the issue. That's the first thing. And then the second here, we only need certain columns. So again, we can only select those that we actually need. So we definitely need this partner ISO. Then we definitely need weights. So we definitely need, or quantity. So QTI. And then finally, we also need the longitude and latitude coordinates of our points. Okay, so this is the first one. And then one last thing is we want to omit any missing values that exist here in this one. The second step is to create our start coordinates. And this is a bit easier because we just need for Ukraine. So our start coordinates denotes the exporting country. And that's of course Ukraine. So start ports equals to, and here we work on the capitals, all right? Capitals, and from the capitals, we filter out only Ukraine. And for that purpose, we use ISO3, and of course UKR, that's the ISO3 code for Ukraine. Okay, so that's the first step. Now the second step is to, basically we need for every part of our data frame here, of this end ports, we need to duplicate these UKR values. So basically for every row of this previous data frame, we need to have this value, which is UKR, in order for us to be then able to later on create lines between Ukraine and these importing countries. So this is how we're going to do that. We are first of all going to group by ISO3. Okay. So first ISO3, we're going to group by here. And then there is a very convenient function in dplyr, which is called slice, which is going to help us exactly duplicate these values for each numbers of rows in this end ports data frame. Okay, so here what we need to do is, first of all, we need to repeat the values. Repeat from 1 to the maximum number of the number of rows of end ports. Okay, so this seems like quite straightforward. So from that one until, so repeat until each equals to the max of the number of rows of end coordinates. Okay, and now that this is done, the very last thing that we need to do is, when working with group by in dplyr, you need to at the end ungroup. So we just need to use here ungroup. And then the very last thing is to simply select only the coordinates. The reason why I'm selecting only the coordinates is that this is going to actually be the same throughout. It's just going to have the coordinates for Ukraine and only for Kiev as a capital of Ukraine. So I'm here only selecting here longitude and latitude from this data frame. In this section, we will connect the starting and ending points, thus creating the trade lines. And the first step in this process is to create a unique identifier for each of the lines and pass it to both the starting and the ending coordinates objects. So let's start off with the start chords object, and let's create a line string ID. And let's do the same for the end chords, also creating line string ID. So this is going to be based on the number of rows of each of them, which is equal. So for that purpose, what we need to do here is simply pass here that it's going to be corresponding to the number of rows of either start chords or end chords. Let's, for example, take the start chords. Right, and now we can actually create the lines themselves. So I'm going to call this one with lines SF, and then in this part we're going to be using SF headers to do that. So SF headers has actually a function which is called SF line string. So this allows you, if you have two pairs of points, to actually connect them and then turn them into an SF object. What you need to do though is put together these two different objects, which is start chords and end chords, and actually merge them row-wise. So for that purpose, we'll be using bind rows from dplyr, and then passing start chords followed by end chords. Of course, we're able to do that because our start chords and end chords have the same column names, right? And then once we do that, we need to actually use dplyr arrange and sort this newly created object by line string ID, which is basically our group ID, right? And once we have that, we need to define then what are the columns for the longitude and latitude, and also what is the group ID column. So the longitude one is of course a long, the latitude one is lat, and the line string ID to be used in this process is also called line string ID. Okay, and then the last step here is to, of course, assign the coordinates reference system to this newly created line string object. To do that, we use SF package, and from SF a function called stsetcrs, and we simply pass here WGS84 coordinates reference system. If you explore this newly created object, you will see that we have two columns here, line string ID and geometry field. Unfortunately, we lost all of those previous columns that were interesting for us, and these include the ISO3 code, but also the quantity of the wheat that was exported to each of these countries. So what we need to do next is basically we need to use a column-wise merging and merge this newly created SF object with our previous with our previous end coordinates object, because this is the one that has information on the ISO3 code and the quantity. So this means let's simply update this with lines SF, and as I said, let's use column-wise joining here, and let's join to this with lines SF. Let's join the end chords object. But from this one, we don't actually need all of the columns, as I said before. So we need partner ISO, and we also need quantity QTY. We have the trade routes now in place, and one last thing before we jump into mapping is to get the world shapefile. This is going to be pretty easy because we have Gisco R at our disposal. So I'm just going to call here Gisco R, and then Gisco get countries to get the world map with also national boundaries. So here I'm not gonna take that high of a resolution, so I'm just gonna go for 10, so not very crisp, because we're operating on a world level and I don't want this map to be too complex and difficult to save. And then the one last thing here is I want to get rid of Antarctica. If you think this is wrong or you think it would look better with Antarctica, you can keep it, but I'm definitely gonna get rid of here. So I'm gonna use here Susset, and then for the name English, I'm actually going to exclude where it equates to Antarctica. All right, guys, it's mapping time. And before we jump into writing ggplot2 code, I here define the coordinates reference system that I'll be using in this tutorial, which is a Robinson coordinates reference system. The next thing is, apart from those lines, I would also like to create points which are going to signify the size of the imports of wheat from Ukraine for each of the countries. And these points are going to be located on the places of the capitals of these countries. So here I'm going to create wheat points SF, and it's going to be based on this end coordinates. So right here, what we actually need to do is the following. We will need to, first of all, group by all these partner countries. So using partner ISO. And then once we do that, what I would like to do actually here is I would like to arrange in descending order the quantity of the wheat that is imported. So the reason why I do that is that later on, I would also like to show you how you can label the map with maybe some of the top importers of Ukrainian wheat. So here we use dplyr arrange, and we also use from dplyr descending, which actually helps you, sort in descending order. We also need to ungroup here, as we did before, because essentially what we want to do here is turn this into an SF object so that we can plot it using GMSF. So here we need to define coordinates. The list of coordinates is longitude, latitude, and we also need to define here the coordinates reference system, which is going to be the WGS 84. Okay, now we have all the ingredients for our soup, and let's start off by calling ggplot2. Next, let's add our first layer here, which is an SF object, and actually it's this world shapefile that we created. So that's the data. The second thing is I would like these polygons of countries on this world map to be in dark blue, and I would like the borders to be in light blue. And then the lines and the circles themselves, I would like to choose a contrasting color, which would be orange, which also to some extent coincides with the color of the wheat. So then for the filling color, we're going to take this dark blue. And then for the color of the borders, we're going to go and take light blue. Now, in terms of the thickness of the national boundaries, I'm going to keep them a bit thinner. So let's say 0.2. The reason for that being I would like lines and also circles to be a bit more visible. And because here we are painting the country polygons in a color, we also need to assign it a bit of a alpha value. So I'm going to go here for 0.35, so that it's kind of a more visible what is going on with the lines and of course the circles. The second layer that we're going to add here are the lines themselves. They're also an SF object, so that's why I'm using here GMSF once more. So with lines SF. And then here we have actually our first aesthetic, or first two. The first one is going to be the size, so the thickness of those lines. And for that, I would like to use this quantity, but the quantity here is in kilograms, and some countries are importing quite a lot. So what I'm doing here is I'm going to adjust here, and I'm going to adjust here into thousands of tons. So in one ton, there is 1,000 kilograms. And to get thousands of tons, we need to actually divide this by 1 million. So here you need to have actually 6 zeros. The second aesthetic that I want to use is transparency. So I want higher quantities of imported wheat to have lower transparency, or to be more visible, so to say. So here I'm actually going to use the same thing I did here. I'm just going to divide the quantity by 1 million to get the same unit. Okay, and then we can actually do some other things, which is, for example, we can fill the line. And as I said before, over here we can go with a contrasting color, which is, for example, this orange that we can use. And the same color we can assign also to the external color of the line. Okay, so this leads me to the last layer, which is also an SF layer, and those are those points that we actually created. So I'm going to just add in here with points SF, and for that we can also define two aesthetics, but here I would actually like to go with only a single aesthetic. So here I would actually like to define only the size, and then I can keep actually the alpha fixed. So we can use the same, basically the same thing, size equals to QTY divided by 1 million. And then outside of this one, also we need to define things like, for example, fill and color. For that, we can also use pretty much the same things like we did for the lines. And also, as I said, we can define here the alpha value, maybe 0.85, so quite visible. And also we can define the stroke of those points, let's say 0.25. All right, so now that we define this, we also need to define what are going to be the range of values for the thickness of lines and also for the size of points, but also for the transparency of the lines. So we need to use scale alpha and scale size for that. Let's start off maybe with scale size, which is going to be our main aesthetic. And let's define then the legend title here. So as we said, thousands of tones. All right. And then we also here can define the range that we're going to use. And this one is pretty much depends on your preferences. So what I like to do is take a bit lower starting point and then maybe go to 2. Now, as you increase this maximum, of course, the line becomes thicker and also those points become bigger. So they kind of might end up overlapping with points from neighboring countries that might be importing from Ukraine. And then the second thing that we're defining here is, of course, the range of the alpha or transparency values. So here, what we're going to do is we can also define scale alpha in terms of the ranges, which are going to be pretty much similar. And we might go for, let's say, 0.25 to, let's say, 0.75, where 0.25 is pretty much a lot transparent and 0.75 less so, where the range goes from actually 0 to 1. Okay, and then because, as I said before, I would like to curse this WGS84 to Robinson, I can simply here go ahead and define that my coordinates reference system is going to be the Robinson coordinates reference system. One of the things that we can customize is the legend, and for that purpose we're using guides here. Now, as I said before, I would like size to be the main one, and that means that for alpha I would like to suppress it, and the way to suppress it showing as a legend is just declaring it as none, and then go ahead and declare things for the size. The guide legend here allows us to kind of define things. And then one thing I would like to do is I would like to change the appearance that would be if I just went for the default legend. So for that purpose, I use override.aes, which means basically just override the main aesthetics. And then here we need to define the list of things that we want to kind of override. So one of the things on this list that we want to override definitely is the filling. So filling should be equal to null. The second one is the alpha value. Let's actually assign it a bit more transparency here. And then finally, and most importantly, the color of the lines in the legend. I would like them also to be orange. If I went for a default one, they would be just white. Okay, now that we actually defined this one, we can go ahead and define other things in our guide. So one of those things that we can define here is direction of the legend. So for the direction of the legend, we can go for either horizontal or vertical. I'm going to go for a horizontal because we are dealing with lines, and in that case, I do like them to be horizontal. We can also define the key heights and the key width of our legends. So for the key heights, we can, for example, use something which is a bit thinner, let's say 1.5 millimeters. And then for the key width, because we are talking about the line, this can be quite much longer, let's say 10 times longer, so 15 millimeters. Some other things that we can also define here is, let's say, title position of our legend. I would like it to be on the top. And also we can define the label position, and I would also like the labels to be on the top. So I'm going to just define that here. The number of rows of our legend is going to be 1 because obviously it's horizontal. And I would like the legend keys to be clustered next to each other. Some other things that we can also define is, for example, title, horizontal justification. I would like it to be, centered, and also same goes for the label horizontal justification. So label hdjust, maybe also we can go for 0.5. Okay, so these are some of the things that are concerning the legend itself, but there are also some other things that we can customize, and these are related to the labels. And labels in our plots are different. So we have, for example, what we can use is title and caption to capture information about what is going on in the map and also what is the source. But some things like, for example, axis titles, like for example, x-axis title and y-axis title, this can be empty, and also subtitle can be empty as well. For the title, what we can do is simply describe what's going on the map. So basically, we're just here covering the wheat imports from Ukraine in 2022. And for the caption itself, what we can define here is perhaps the source of the data. I think that would be the most important thing. So what we can say here, basically, it's just, okay, data here is United Nations 2023 UN Comtrade, and then also the link to the data itself. And then we come to the last part, but not least, which is theme. I like to start with theme void and then add some elements as we go. And for that, I just open theme, and then here I define things. So one of the things I would like to have is the background in also dark blue color, the same as those polygons of the countries. So for that purpose, I will define here plot.background. And because this is a rectangular element in the vocabulary of ggplot2, I need to put here that it's element rect. And then for the fill, I'm going to use the same dark blue color as we used for the country polygons, and leaving here the missing value for the color of the borders of the plot background. The same thing we did for the plot background, we should also do for two more elements. One of them is the panel background. So this is the overall background around the map itself. And the third one is the legend background as well. All right, now that we define this, we can also define the legend position relative to the map. And here you can either describe where you want it to be, top, bottom, left, or right. Or like in this case, I would like actually to place it in a specific spot. So I would like, first of all, that legend to be centered. And second, I would like it to be somewhere, maybe let's say around 0. So somewhere on the bottom, just below the map itself. Okay. Now there are also other things that we need to fill up with the color, and one of them is this panel .grid.major. So these are the major grids on the map, which actually we might not need to define since we're using theme void, but given that we're changing color, I always like to kind of make sure that we are kind of doing it. So this one is line, so we need to define here that it's element line. And then within this one, we need to define the color. So the color is also going to be the same as this one. Size is not that important, so it can be, let's say, 0. This is just a precautionary measure in terms, in case that the theme void does not really work. We're using title and caption, so we should also kind of customize those things. Both title and caption are text in ggplot2 vocabulary, so that's why I'm here defining them as text. We can define here the size. Let's say it can be 22, the size of the title. And for the color, I would like to keep the same color as the lines, so that would be that orange color. And I would like it to be centered, and perhaps I would like to move it closer towards, away from the map. All right. Similarly, we can define here the caption. So it's again text. So for the caption, we can choose something, let's say smaller, let's say for example 8, and it doesn't need to be orange, doesn't need to stand out that much. We can go for some kind of a very light gray. And also in terms of the horizontal justification, it can be somewhere towards, the left-hand side and also towards the bottom. Okay. There are also some other things that we can define here, and one of them is, for example, a legend title. So legend title. So for the legend title, we can go ahead and choose something also smaller, let's say 9 pixel size. And we can also go for this color, this orange color. The same way we define this, we can also define the legend text. And I would also like this one to be in orange color. Legend title perhaps should be a bit larger. So maybe 10, and this one should be 9. All right, and then one of the last things that we can define here are the margins of the plot. So some parts of the plot we can expand, other parts of the plot maybe we can shrink. So this is what margins are used for. Now the way that it works is you here define a list of each with all the sides. For the top side, we can add a bit more space due to the, of course, the title. For the right-hand side, we can shrink it by 2. For the bottom side, maybe it can be like 0.5. And then for the left-hand side, we can go also and shrink it a bit. And then here, just define the units that we're using, and these are going to be lines. All right, so once we actually run this, this was actually quite a long code. So this one is going to produce our map. Now, the thing is, we also might want to save this locally. So for that purpose, we need to use ggSave, which actually saves this object. So maybe this one we can call Ukraine export wheat, and then no label. So in this version, we're not going to go for a label. And then we can also define here the width and the height, which are in inches. So the width is going to be, it's going to be a bit wider. And also because we're here dealing with the PNG formats, I'm also defining here the dots per inch. Device, of course, is going to be PNG, which we already defined. The background, well, background's not really going to be white, but it's more going to be this color that we defined. Usually I define in white, but this time it is different. And then also the final part is passing here the name of the ggplot object that you want to save. Okay, so if you run the code and there are no errors, you're on the safe side, and you should be able to see the map that looks like this. So we have a dark blue background, we have the light blue color of the national lines, and of course we have the great circles of these trade routes ending with dots at every end, and each dot is adjusted by the size of the wheat imports for Ukraine for these countries that are importing. Of course, the thickness of the line and also the transparency level is adjusted, and it is adjusted by the quantity of those imports. There's also legend at the bottom. There's also the caption suggesting what is the source. But if you want to enrich this map a bit, you can also add labels. Let's say we want to label the top 5 largest importers of Ukrainian wheat in 2022. We can also do that. And I'm going to now show you how you can do that. Okay, so adding labels or text to your ggplot2 based on the GeoMSF object is pretty straightforward. So I'm going to start writing here just right after this last layer that we added. And for that purpose, I'm going to be using GeoMSF label. Now there are 2 arguments here. One is this one I'm using. This is going to create a text and some kind of a background around it. So it's going to be more like a sticker. And there is another option is to use GeoMSF text. So this is just going to print any text that you put there. All right, so here's how we're going to do that. First of all, we're going to use the data here, which is going to be those wheat points. So wheat points SF. And then we're going to only select the first 5 rows. Remember that we did sort this one by the quantity at the beginning in descending order. So this allows us to take the 5 largest importers of Ukrainian wheat. So here I'm taking only the first 5 rows, and then I here need to define the main aesthetics for this one. And the main aesthetic here is called a label. Now for the label, what we can do is we can, for example, have partner ISO, or for example, country name in case you actually kept this one while you were doing the analysis. And the second one is the quantity, which can be also adjusted here by 1000 in order to reflect, of course, the legend that we will have. Now we need to actually put this together and use here paste 0, but we also need to make sure that of course this one does not produce decimal values, so we need to round it, and let's round it to the whole number. So here we put 0 for that purpose. And also let's make sure when we're using here paste that there is some kind of a space between these two. First of all, let's use here colon, and then let's add some space as well between the ISO3 code and then this import quantity. Okay, so within GeoMSF label, this was the main layer, but you can also kind of define here some other things. And one of them is size of the font. I go here for 2. You can play around with this and see what works for you. Of course, if you increase the size of the font, it's going to be much bigger, and that also means the label is going to be bigger. So be careful about that. You can also here readjust your vertical position. So 1, if you want 1, it's going to go more to the right hand side. If you put, for example, 0, it's going to go more to the left hand side. So that's actually, this is for the horizontal justification, what I was saying about. If you choose something like this for the vertical, 1 means it's going to move more towards the north, and 0 is going to move more towards the south, right? So these are some things to consider. Of course, you can also change the color of the text, and here we can go again for this orange value that we used before, and you can even decide on the transparency of your labels, which means also on the background where the layer is. You can define, for example, 0.85. So alpha here goes from 0, which means completely transparent, which means invisible, to 1, which means not transparent at all. Okay, so now that if you actually run this whole code, including this what we defined here, if you run this whole thing, which is quite long, and also this, you should be now able to see, well, basically exactly the same map with one exception, and those are those 5 labels labeling the country ISO 3 codes and the quantity in thousands of tons of wheat. And you can clearly see that most of the countries are actually in Europe, but there are also some in Asia and Africa that imported a lot of wheat from Ukraine in 2022. So far, I showed you how you can map imports and trade lines only from a single source. But what if you want to build a trade network? What if you want to see how, for example, trade routes look if we have multiple exporters? So in this part, I want to show you exactly that, how we can include more than just Ukraine. So I went online and searched, and some of the biggest exporters together with Ukraine are also Australia and the United States. So I'm just going to add them here. I'm working here on the code that we did previously where we just used Ukraine. The only thing that we need to add here is the following. So we need to have Ukraine, and then we can add here Australia. So this is ISO 3 for Australia, and then USA is for the United States. So in our first take, we only cared about partner ISO 3 codes and also the quantity because we only had one source of exports, and that was Ukraine. But this time we have 2 more, so we have 3. And apart from partner ISO, we also need to add here reporter ISO so that we capture all of them. When it comes to the ending and starting coordinates, the changes are again very minimal. So what we need to do here is simply add reporter ISO to the selection of the columns for the end coordinates. Everything else remains the same. And then for these start coordinates, we do need to actually change something. So for the start coordinates, we used to take only the ISO 3 code for Ukraine, but now we have 2 more. So things are a bit different. So they're different in the following way. First of all, we're not going to here filter by Ukraine. What we are instead going to do is we're going to select everything from, of course, the capitals, except for 2 things. And we are actually not going to work on capitals here. That's also a new thing. We're going to work here on end coordinates. And we're going to work on end coordinates because they have already all the information we need. So the only thing we will not need here is the longitude and latitude. So we're going to exclude them. And you will see why. We're going to exclude them because we're going to join to capitals now, the capitals data frame. So for that purpose, we're using left join from dplyr. And then for capitals, the reason why we are joining to capitals is because we want to also get the ISO 3 codes for both the US and Australia. So for that purpose, we are here joining on reporter ISO, and then reporter ISO is going to be equal to ISO 3, which comes from the capitals data frame. All right, so that's it. Here we don't need to slice and dice anything that we did before, so that's totally unnecessary. We only need to now select the columns at the end that we will need. So we again go for dplyr select, and of course, yes, we will need partner ISO 3, but we will also need reporter ISO, And apart from that, we will also need quantity, and we will also need longitude and latitude. And then at the end, we can also here simply also omit any kind of missing values that there are. And for the part where we actually create the lines based on the starting and ending points, there's also not that much. Basically, this entire part where we create the lines stays as is. The only difference is where we attach the columns that are missing. Now, apart from partner ISO and the quantity, what we also want is to get the reporter ISO as well. One difference compared to the first plot is that here we will need to have colors for each of the exporters. So here I define simply 3 colors that are different enough so that we can make a difference between the US, Australian, and also Ukrainian wheat exports. Finally, when it comes to the map itself, I also want to make several adjustments, but they're mostly cosmetic adjustments. One of them being that here I would like to have a gray background, simply for the reason that now we will have multiple colors, and actually if I put blue, maybe some colors will be too complementary to it. So I'm just gonna go be on the safe side and choose charcoal gray for the filling of the polygons as well as the map background, and go for the light gray when it comes to the color of the lines. Other things I'm gonna more or less keep here. Perhaps I'm just gonna delete here the alpha value. Then moving to the wheat lines, we can keep these things. Now for the fill and for, of course, the color, what I would like to have here is the reporter ISO. So I don't want it fixed. And also here I would like reporter ISO. And of course that means that both the fill and the color we need to put inside of the aesthetics here. So that's the first change. Within this one, we are not going to have points here, so I'm just going to remove them just to decrease the complexity. Same goes here for the labels. I'm also going to remove that. Now, when it comes to the size, I think for the size, of course, we can play here a bit. It doesn't need to be the same. I am going to increase both the minimum and the maximum values here because we are going to have several sources, and I would like to kind of accentuate more some. Also for the scale alpha level, it is going to be maybe a bit different. I'm going to also readjust and go for the maximum alpha value, but also something closer to the minimum value as well. We're going to go also again with the Robinson projection, so that's going to stay the same. We do need to add 2 more things here, which is scale color manual and scale fill manual, because as you remember, we also added those. Let's start with the scale color manual. This one actually is going to have 2 things. Well, we're going to omit the name of the legend because it's already on the size level. And then for the values, we're just going to use those calls that we previously defined. For the scale fill manual or scale fill manual, it's going to be basically the same thing. So we can just copy and paste here. Okay, now for the guides, things also need to change here because apart from alpha now, we also have color, which also needs to be none, so I don't want to show it. And also fill also needs to be none. All right. This actually remains the same, although for here for the color, I am gonna actually put this maybe even to white because the background is like charcoal gray, so it's gonna be a nice contrast. In terms of the direction here and other things, this actually remains the same. Same goes for labels. Now, when it comes to the plot background, of course, here, because I turned everything into charcoal gray, I'm going to continue with this trend as well, and simply just changing these blue values here or dark blue values with charcoal gray. Similar things goes also for the title. So the title can go either to white or maybe gray. Let's say it goes to white. Also for the legend title, Sing Destiny, it goes into the white. All right, margins are gonna remain the same, so I don't have any problem with that. So background, finally the background should be also charcoal gray. And here what we are actually doing is not Ukrainian anymore, but I would say just like multiple export wheat. And here actually we don't have a label, so we can just delete this. And then once we actually run this whole thing, including the color palette, what you should be able to see now are lines with these 3 different colors showing basically the network of wheat exports from these 3 centers, some of the major actually exporters of wheat. And this is a really nice way to visualize actually what are the important exporters, but also what are the importers, the greatest importers, and whether there are some countries that may be importing from more than one of these biggest exporters of wheat. And that's all for today, folks. In today's tutorial, we use Comtrade data to create some awesome global circle maps. And if you are interested in replicating today's analysis, I've prepared a link to the GitHub repo in the description box below, so do check it out. Feel free to clone it, modify it, reuse it as you see fit. I'm really looking forward to your own use cases and how you take this tutorial on a journey across the world and also create some really awesome global circle maps. If you have any comments or questions or feedback, feel free to reach out to me here on YouTube, but also on Instagram and X. If you're new to R and you seek to expand your knowledge of data visualization and geospatial analysis in R, I've prepared a few cool tutorials for you, so do check them out. See you next time.